Hi, in this video we wanna show how are these exponential graphs and this special exponential graph can draw. Please see this video at the end. You will draw them easily. Okay, let's start with e powered by x powered by 2. So at first it's better to remember something about the uh, even and odd functions. So when a function, say if we say we find f of minus x is f of x, it will be even, and if f of minus x is minus f of x, it is odd. And if f of minus x is not equal by them, it will be neither. Okay, let's draw y equal e powered by x squared. We remember how to draw the y equal e powered by x. At first, let's check if it is even or odd, because if you make f of minus x, if it will be e powered by minus x squared. Exact, it is e powered by x squared. So the even function are reflect by y-axis. Only need to draw the part of x bigger than 0, and after that you can reflect it easily. Okay, and this usually the odd are reflect with origin, reflect with origin 0 and 0. Okay, now we know it is even, or even exponent are even, usually function are even. So let's draw better. This is my axis. At first I remember that how to draw the graph of e equal x squared. E equal x squared. Now let's draw it. It passes from 1. I told you only need to draw positive x's. Only need to draw positive x's. And excuse me, and easily you can erase this part. Let me erase this part till here, and after that reflect to y-axis. So reflect to y-axis. This is my graph of y equal e powered by x powered by 2. Now let's solve another graph. So we have y equal e powered by minus x squared. We know that minus x squared is again even. Minus x squared is again even. Before solving it, let's solve the another example for e powered by x plus 2 plus 3, x powered x squared and plus 3. Okay, again it's easily you can draw e powered by x squared, and after that shift on y-axis 3. Easily I draw. I know my graph should be like this. This is the first graph, y equal e powered by x squared, and after that only need to shift it 3. 1 2 3, so it is in number 4. Why? Because it was 1. Okay, now draw it again. So it is the graph of e powered by x squared plus 3. This is the graph. Let's solve another example. We have y equal e to the power x minus x squared. We know it is even again, because if we find f of minus x, it is e powered by minus x squared. Again it will be e powered by minus x squared, and it will be f of minus x, f of x. So it is even. Only need to draw x bigger than 0. Okay, we remember how to draw y equal e powered by minus x. If you want to check it in this previous video, you can see how draw exponential graph in the graphs, drawing the graphs. Look at here, e powered by minus x. I know it will be in quarter number, it will finish in quarter number 2. It will finish in quarter number 2. So I started here, go past 1 and finish in quarter number 2. It is 1 here, but I need the positive x part, so easily I should erase it. Okay, and reflect, because it is even, and reflect to the y-axis. So sorry, it is not good. It is the graph of e powered by minus x squared. Let's draw another graph. It is the example we can shift it e powered by minus x squared minus 2. Easily I draw e powered by minus x squared. After that, shift it to down. So I try to, but it is not good. This is the graph of e powered by x minus x squared. Now I want to shift it down. How much? 2 down. So 2 down is 1, 2. It will be on minus 1. Now easily I can draw it. But I have here a horizontal asymptote. We know that in exponential graph we have horizontal asymptote. So here I have horizontal asymptote in y equal minus 2. Okay, I find minus 2. It is the horizontal asymptote. And now I draw it. It is the graph of y equal e to the minus x squared minus 2. Okay, when you have here number for y, it will be your horizontal asymptote. Let's solve another graph. Y equal e to the x cubed. Because we have e to the x cubed, it is odd. It is odd function. It should have an inflection point. So easily I know how to draw e powered by x. How to draw e powered by x? I know it is e powered by x. Okay, because it is not even, I can erase the positive part. No need. Excuse me, it is odd. No need positive part. So now I should have inflection point here. I should have an inflection point here. And in inflection point usually you have the horizontal gradient. You have the horizontal gradient. It's better to draw it like this, because here we will have a gradient. It's better to draw like this. It's go here. It is 0 gradient, and after that I can continue it as the before. It is like graph of x cubed. It is like the graph of x cubed. On 1 we have an inflection point. In inflection point the gradient is horizontal. So you see here it is like the x cubed graph, but only need to add to e powered by x. Easily we can draw. Only need to remember how to draw the e powered by x cubed. After that, by adding number and minus number you can shift it. Okay, let's erase it. Go to the next example. Y equal e to the x cubed minus 4. I know I can draw it easily on minus 4. So what happened in minus 4? In minus 4 I will have a horizontal asymptote. On y equal minus 4. Let's draw my asymptote here. Suppose that here is minus 4. And I should start from top of here. Here on minus 3 will be my inflection point. Inflection point always is 1 bigger than this. Now I should continue it as the form of x cubed. It will be my graph. On the other hand, you know y is positive, x is positive, so it should be in quarter number 1. It should finish in quarter number 1. So it is in quarter number 1 we finished it. Let's draw next. If y equal e to the minus x cubed. As we know, again here y is positive, x is negative, so it should finish in quarter number 2. It is exact e powered by x cubed, but only finish in quarter number 2. So easily I can draw it. So what is my horizontal asymptote? I don't have here, so y equals 0 is my horizontal asymptote. And it goes to 1, continue as x cubed. So it is my graph. And it finished to quarter number 2. Let's solve another example. Y equal e to the minus x plus 2. Again it will finish in quarter number 2, and it should have shift minus 2. At first I find should have shift on positive 2. At first I find positive 2. Let's draw by another color or asymptote on 2. Okay, let's draw it. I know that it will finish in quarter number 2. So I start and always it should be 1. The inflection point is 1 more than this. It is on 3. On 3. This point is 3. Let's draw e to the square root of x. y equal e to the square root of x. We know of square root of x how to draw, but here we have e to the square root of x. So to find this, usually it is positive, so it will be finished in quarter number 1. To draw it better for all you can give point. You can give point for x and y, but the whole shape should be like this. It's very easy to draw, only need to give point for x and y. So if x equals 0, y is 1. If x equals 1, y is 2.72, because e is 2.7, and x is 2, y will be 4.11. Okay, now I can find this point and start. Always start from 1 if you don't have any shift on y-axis. So if x is 0, y is 1. It is the first point. If x is 1, y is 2.72. It will be the next point. If x is 2, y is 4.11. Suppose that here. It is another. Now I want to draw it. Easily I draw it. It is the shape of this graph. Go to the next example. The next example is y equal e to the radical x plus 3. I know that it will finish in quarter number 1, and I know the shape of this should be like this. Easily I can shift it 3 up. If I go 3 up, it will be on 4, because it was in 1. 3 up, it will be in 4. Now easily I can draw. If you want to know to draw it better, you can give point for x and y. If x is 0, you can find by better is if x is 0, y is 3, y is 4, excuse me. E powered by 0 is 1 plus 3 is 4, so it means it starts from 4, and you can find the other points by this way. Let's go another example. I have y equal e to the minus radical x. I know it will finish in quarter number, because it is positive. In quarter number, y is positive, x is negative, so it will be in quarter number 2 will finish. But no need this. Look at here what will happen. I give point x and y. If x is 0, y should be 1. If x is 1, y should be 0.37. If x is 2, y should be 0.24. Now let's draw it. the hidden part should be go in the quarter number 2, but let's at first find the points. So 0 and 1, it means it passed from the SP. Why? Because we don't have any Y here. 1 and let's draw it bigger. Yes, I think it's better to draw it bigger. Suppose that my 1 is here. It is 1 and 1 2 3 4 1 2 3 4. It is one of x-axis and one of y-axis. Now suppose that it is the first point. 1, it is the first point. 1 and x is 1, y is 0.37, and after that is 0.24. Let's continue my graph because I need x2. If x is 2, if x is 1, it will be 0.37. If x is 2, it will be 0.24. So I know my graph passes this. It is easily we draw it, and I have the horizontal asymptote. It is y equals 0. Let's solve another example, and this will be the last example for this video. I have y equal e to the radical x plus 2. I know I don't have a horizontal asymptote. It is I have usually, but it is in y equals 0. It means it is in x-axis. Okay, let's draw it by giving some points. X and y. If x equals 0, suppose that start with 2. 0 is not very helpful. If x is minus 2, because I need to make it 0, e powered by 0 is 1. If x is minus 1, e will be, y should be 2.72. It means e. And if x is 0, it is 4.11. Yes, we can draw it by this point. Okay, so at first minus 2 by 1, this point. At the second, minus 1 and 2.72. Minus 1 and 2.72, something here. And next is 0 and 4.11. It means here 4.11, and here is 2.72. Now I draw the graph easily. It is the graph of e powered by radical x plus 2. Okay, I hope you understand them better, and thanks for watching this video, and have a good time.